Okay, so first one should be straightforward as long as you still remember the definition of the Wronskian. Right, so the definition of the Wronskian is that is what is it? It's y1, y2, y1 prime, y2 prime. Right. So then your y1 is your sine square x, your y2 is your cosine square x. Right. So then I have this sine square x, cosine square x. So y1 prime is 2 sine x cosine x. Right. y2 prime is minus 2 sine x cosine x. So take this determinant. Right. So then you have sine square x. So both I will have this sine x cosine x as a common factor. Right. So I just have this minus 1, minus 1, minus cosine square x. And then the common factor is 2 times sine x cosine x. So then this would be, so minus sine square x minus cosine square x is minus 1. So it's minus 2 sine x cosine x. So of course this is not always 0, right? So then that means this determinant is not always 0. There's some many values of x such that this determinant is non-zero. So that's why sine square x and cosine square x are linearly independent. So if sine square x and cosine square x are linearly independent, okay, so then what part B, part 2 asks? Okay, so it asks that instead of saying the general solution to be a linear combination of sine square x and cosine square x, it asks whether we can treat, okay, 1 and cosine 2x as the two solutions, okay, and then say that this linear combination of 1 and cosine 2x to be the general solution of the equation. So if this one, right, so equivalent to this, okay, that's the question. Right. So first of all, we can prove that 1 and cosine 2x are linearly independent, right? So that's no problem. Again, using Wronskian or just taking the ratio, right? So that's don't need to repeat that. Okay. So now you see that this sine square x, cosine square x, then how do I convert it into 1 and cosine 2x? So you might still remember, so this is a trigonometric formula that you need to use. Okay. This cosine 2x is actually equals to 2 cosine square x minus 1. Right? Or it is equals to 1 minus 2 sine square x. Right. So that means when I write this, or let me do one more step. So that means, right, cosine square x is equals to 1/2 of equals to 1/2 of 1 plus cosine 2x, right? And then this sine square x is equals to 1/2 1 minus cosine 2x. So that means this C1 sine square x plus C2 cosine square x is written like this, right? So C1 times 1/2 1 minus cosine 2x plus this C2 times 1/2 1 plus cosine 2x. And now you can actually try to group the terms. You see that it is equals to C1 plus C2 divided by 2 times 1 plus C2 minus C1 divided by 2 cosine 2x. Right. So then that means you can see that the solution, the general solution, right? So if you say that the general solution can be written in this form, then that is equivalent to say that the general solution can be written in this form also. And in this form, you can see that I can write it as some constant times 1 plus another constant times cosine 2x. So that means once you say that sine square x is a solution, cosine square x is another solution, then I will also know that 1 is a solution and cosine 2x is a solution. So then this is give us some useful information actually. So if we want to find out, okay, px and qx, so then what do we need to do? We try to substitute. Okay, we try to substitute these two known solutions, okay, back to the equation. And what do we got? Now 1 is a solution. So then if I substitute this 1 back to this equation, okay, what do I get? So then it's the derivative of 1 of y is 0, right? So then these two terms is 0. So that means that q of x times 1 is 0. So that means actually, okay, q of x is 0. Okay, q of x is 0. So now I also want to find out p of x, right? So what I do is that I substitute, okay, so the other solution back to the equation. So that means I want to do this d square dx square cosine 2x plus p of x d dx cosine 2x. Okay. And the q of x I just found out is 0. So that means these two terms added together is 0. Okay. So then this d dx cosine 2x, what does it give? So it's this minus 2px sine 2x. And the first one, right? So derivative one more time. So take one derivative is minus 2 sine 2x. Derivative again, so it's minus 4 cosine 2x. These two have to be 0. So then you can find out p of x. P of x. So p of x, what is it? It's 2 times cosine 2x divided by sine 2x. So then that's part C. Okay, so finally, okay, so this is something, okay, maybe don't have time here, but for you to try to do it at home, is that now, so this is the homogeneous one, right? So now I make it to become non-homogeneous. okay, by adding this non-zero function on the right hand side. Then you actually know what to do, right? You actually know what to do. Although now I don't have these to be constant coefficient, but as long as it's a linear ODE, right? So it can be written as, right? So complementary solution plus particular solution. Okay. Complementary solution we know already. Okay. And the particular solution again is the same. Is the same strategy. Okay, same strategy. So whenever you see the sign function, right? So the particular solution that you have to try is some constant, right? Cosine 2x plus some constant times sine 2x. Right? This is always the form that you are going to try. But one more time, here again, you need to be careful. Is that because cosine 2x by itself is already a complementary solution, and we want to make sure that, right? So the particular solution not linearly dependent, right? So to the complementary solution. So that's why when you try the particular solution, again you need to multiply this cosine term by x. And then you substitute it back to the equation and find out the appropriate value of a and b. Okay, so I think that's all for today. Okay, so for the other question, I will try to get to that next time.